a Milwaukee Rocket Light. Now, I bought this off eBay for spares or repair, and I paid, I think it was about £63 for it. And the retail for about £220 to £300. So, if I can fix it, it's probably not a bad bargain. Right, it's just described as dead on the listing. I'll just bring the listing up so you can have a look. So, we'll pop a battery in. The battery goes in the bottom here. And it's a fully charged battery, and this is the power button, so we'll press it. Yep, and it's correct, it is dead. So it's a little bit big to fit on my blue mat, so I brought it into the workshop so we can have a look at it there. So I'll put it back down and we'll put it on the bench and we'll see if we can figure out what's wrong with it. Right, so I've got it on the workbench now, and the first thing I've noticed is there seems to be a little bit of corrosion just down here, as you can see there on the battery terminal there. So I think the first thing I'm going to do is try and remove this bottom section of the light, and we'll see what's going on with the battery terminals. So the first problem I've come across is my normal Torx drivers don't actually reach far enough to get to the screws. But luckily I've got these big long ones that I bought a while back when I was working on a Milwaukee radio, so these fit. And this is a T15. So we'll start by undoing the screws, and there's about 1, 2, 3, 4, 5. There's about 8 screws on the bottom, so we'll undo those. Right, there's actually 10 screws on the bottom, and then this bottom section comes off. And it looks like we've got a circuit board in the bottom here. Now, most of the Milwaukee lights that I've worked on, the problem has actually been with the circuit board. So hopefully, once we get this out, we might need to disassemble any more of it, but we'll obviously find out. So it looks like there's 4 screws hold this battery plate on, so we'll take that off. And it looks like there's 2 screws hold the circuit board in. This little bracket here. Right, so there we go. Well, this board looks quite similar to one of the other Milwaukee lights that I've worked on previously. I wonder if it might be worth taking this over to the blue mat so we can inspect it and do some further tests on it. Yeah, I think I'll do that because then I can zoom in and stuff. Right, so I've got the board over on the blue mat now, so we'll have a quick look over the board just to see if we can see anything obvious. And like I say, I have worked on lights that have a similar arrangement to this before. So what have we got then? On the other light that I looked at, I believe this was a dual MOSFET. And I think that was switched by this microcontroller chip here, which what the microcontroller is there for, it detects when you press the power button, which plugs in there. And it also, when you press the button again, it adjusts the brightness. I think it uses pulse width modulation to control this chip here, which is the LED driver. And that's how it controls the brightness. And also what the chip does, it measures the battery level. One of the other lights I had a problem with, there was a resistor over here somewhere, and what it did, it measured the battery voltage, and once the battery voltage dropped below a certain level, the microcontroller would then disconnect this MOSFET, or tell this MOSFET to switch off, and disconnect the power from the battery to the LED driver. So that's pretty much how the circuit worked. So what's going on with this then? What can we check? Well, it looks like the power comes in here, and then it looks like we've got a fuse here marked F1. I mean, I can't see anything blown on the board. There's nothing really on the back of the board as such. So I think what we'll do is we'll check this fuse here, because that's where the power comes in, and obviously it won't do anything if that's gone. So I'll get the test meter, we'll put it onto continuity, and we'll just check that fuse first of all. Right, so meter in continuity, and we'll just check this fuse here. And the fuse is intact. Okay. Right. Let's just zoom back in again. Now, one thing I have noticed is the capacitor here is rated at 50 volts, but we've only got about 18 volts coming in on the power. So I can't remember whether this actually steps up the voltage to the LED. And I think the two pins where the power comes out to the LED head are here and here. So we're going to just double check on this capacitor here. So let's just double check that. So again, I've got the meter in continuity. I'll just zoom out a fraction more there. And we'll just check that that goes to that pin there. And I think that goes to the first pin if I remember right. Yeah. Right, so the reason we've got 4 pins here is the first 2 are the power to the actual LED head, and the other 2 connected to a thermistor that's in the LED head as well. So in case the LEDs overheat or get too hot, that sends a signal to the microcontroller, which then also disconnects the power. So like I say, the microcontroller is responsible for the overall management of the light. Right, I think I'll connect some power up and we'll just see what voltages we're getting here. So I'll connect the battery up. So let's put the meter onto volts DC. And where's there a ground? Let's see where the ground goes. So the ground comes down here, it goes along and it goes to the top pin of this capacitor. So that should be a ground. And we'll just check that we're getting 18 volts, or 20 volts rather, because this battery's fully charged. So yeah, so we're getting power to there. So obviously we'll just check the fuse and that's okay. And then goes to here, which is one of the pins on this dual MOSFET. I wonder if we've got any power on this microcontroller. So we'll just try a few of the pins on here. Yeah, so we've got 3.3 volts there, and that's probably a 3.3 volt regulator. Which, yeah. So the voltage regulator here, that's what powers up the microcontroller, and that's working as well. So we're getting power to the board, but the light isn't lighting up. So either the microcontroller is sensing there's a fault somewhere, because like I said, I had one where the microcontroller thought the battery was flat, so therefore it wouldn't switch this LED driver on, or there's a problem with the LED driver circuit. So I'll tell you what I'm going to do. I'm just going to simulate pressing the on-off switch just by poking a bit of metal in here. So that should have told it to switch on. And I think this capacitor here is where, when the microcontroller is happy, it switches the power onto here. So let's see if we're getting any power on this capacitor. And we don't appear to be. Just double check that again. Yeah, so as you can see, there's no voltage on this capacitor here. So there's no power getting to this chip. So from what I remember, I'll pull the data sheet up on this chip actually so we can have a look. Right, so according to the data sheet, the power comes in on pin 12. So there's pin 1. I'll just zoom in a bit so we can see that. So pin 1, and that's pin 8, 9, 10, 11, 12. So it actually looks like 11 and 12 are joined together. It's a bit hard to see. I'll just zoom in a fraction more. Yeah, so 11 and 12 are joined together here, and they go to that capacitor here marked C1. So we should have power. If that chip's being powered, we should have power on there. So I'll just zoom out a touch so you can see the meter. I'll try and give it a bit more shot there. So if I go into ground on this capacitor here, and we're not getting anything. So it doesn't appear that this chip's getting power. This is the output from the chip. So if this chip was getting power and it wasn't working right, you wouldn't get any power on this one here. So, and obviously we're not, because we're not getting any power into the chip. Because if we were getting power here, then I would say the fault could be from the wiring, from this plug here, going to the LED head or the LED head itself. Because we're getting no power here, the fault definitely seems to be on this board. Right, I think we'll have a look at this MOSFET just to see, because that could have failed. I doubt it, but let's pull the data sheet up for this and we'll check some voltages on that. Right, I'll just zoom in a bit. So on the data sheet, it says this is the, because there's two MOSFETs in this package. You can think of like that being one MOSFET at the top here, and the bottom half of the chip here being another MOSFET. And what happens is, this is the source, so that's where the power comes in, and these two pins are the drain for this particular half of the chip. So it's like when the microcontroller sends a signal to this pin here, which is the gate, it effectively sends the power from here to there. So to test even the LED circuit, what we could do is just bridge from there to there, and that would effectively power up the LED half of the circuit and send power to the connector. So I think what we'll do, we'll just measure some voltages. So I'll just zoom out a bit and get the meter in shot. So I'll use this pin as a ground again, and we'll just check we're getting a voltage there, which we are. So the input pin is this one here, and as you can see we've got 20 volts, and on the output pin we've got nothing. Now to drive this MOSFET we need to pull this pin low, which is the gate, and that's high at the moment. If I can get the probe on there properly, it's a little bit tricky. There we go. So as you can see, the gate pin is still high at the moment, so that's telling the MOSFET not to turn on. We need to actually ground this pin to turn the MOSFET on. So like I said, more than likely that MOSFET's working, so we need to work further back now. So it looks like the gate pin's connected by these two transistors here. The gate pins going to this MOSFET rather. Looks like one goes to that transistor there and one goes to that transistor there. So let's just see if we've got any voltages on those. And we have nothing on that one and nothing on that one. Well, we've got power going to the microcontroller. So why isn't the microcontroller telling this to switch on? So the on-off switch connects here. Let's just check the continuity, see if we get that. Tell you what, I'll unplug the battery a second. So this is the on-off switch here. Let's go into continuity a second. So let's just try that pin. If I can get the meter probe on, it's a bit tricky. And we'll just check between that and ground, see if we get anything. Nothing on that one. Right, so I'll just show you what I'm doing there because you can't quite see. So I'm just going between the ground pin here, and it looks like that one is the ground. Because normally what happens is one end of the power switch, when you press it, would be connected to ground, and the other end is normally connected to something like the 3-volt line through a resistor and to one of the pins on the microcontroller. So let's just check this. So we'll go on there now and just try the pins on the microcontroller. I don't seem to be getting anything there. Yeah, let's try it on ohms. Let's just well, I'm definitely on the pin because I'm getting some kind of reading, but it looks very high. I would have thought maybe something about 10k or something like that. Let's just check between that and the voltage regulator. So it still seems very high. That I would have thought about 10k or something if I was going to get anything. Either that or just a direct connection even. Because some of these microcontrollers have a built-in pull-up resistor, so they don't even need an external resistor. I think I need to remove some of this goo and try and figure out what's going on under here. Now normally I would heat this yellow stuff up because that's the easiest way to get it off. But I'm just worried about melting these plastic connectors here. I still might have to do that and just you know, just try and be a bit careful. Either that or try and cover them up with some Captain tape or whatever. Right, so I've just heated it up a bit with the hot air gun on the hot air rework station, and hopefully we can get some of this off. Alright, I think I'll have to put a little more heat on it now. I'm just going to try and get me tweezers. Right, so it looks like that pin goes to that there, and it does go through a resistor. Oh. Come on camera, focus. Yeah, so it looks like it goes through a 330 ohm pull-up. Right, let's just see if we get a reading from right, let's bring the meter in. We'll see if we get a reading from there to there. And we do. That's a bit odd. Try and get the camera to focus it. Now look, here we go, that might be the problem. It looks like we might have a bit of corrosion. It looks like on that wire there, because the other side of it looks fine. Like I say, that's the other side of it there, that looks fine. But then it looks like the signal from the on-off switch isn't making it down to that point there, which again is under some goo. Anyway, let's just measure the resistance from there to there. I'll just zoom out a bit. Right. Yeah, if you can see the meter properly there, I'll just get that in shot. Yeah, I think that's the problem. I think that vire's gone. I think there's a bit of corrosion getting in there, and it's took that wire out. So hopefully we should just be to solder a wire on the other side of this wire and solder it to this point here. Right, so I shall go get some wire. Right, I've got a bit of wire there. I've just tinned the end of it. So if I poke it through this hole here, it's actually a slightly different wire to the one I thought it was, but it is actually connected to the same place, because the on-off switch comes there, then goes through that 330 ohm resistor, and then to the wire that's failed, and then it probably comes back to somewhere around about here, and then goes into the microcontroller. Maybe on that one actually. So right, we'll solder that up then. Right, I'm just going to get a bit of flux on there. Do. I'll just snip off the excess wire. Just get the tweezers a sec. Right, and then we'll solder that up. Right, as easy as that. Right then, I think we'll take it over to the other workshop now and see if it works. Right, so we're back over the other workshop now. I think I'll get a bit IP and I'll clean this connector up a little bit as well. Right then. Let's see if it does anything now. Well, that looks a good sign. Right, so I thought I'd set it back up in the corner of the shed here, and we'll switch it on. And there we go. No longer dead. And I should be adjust the brightness. There we go. I need to remove the dead sticker still, but yeah, I'm quite happy with that. Right then, if you enjoyed this video, please give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comments section below. And as always, have a great day. Thanks for watching.